Now we're gonna recall factoring. I remember back in the days, I used to tell you guys that if you were to do the square root on each side, the square root of x squared is x, the square root of 9 is 3. If multiplied was equal to half of the middle term, we had what we call the perfect square. We respected the sign from the middle, so we're gonna go x plus 3 all squared. The same thing with my other example here. I just added this slide, so it shouldn't be on your slides. Square root of x squared is x. The square root of 25 is 5. If I multiply them, is equal to half of the middle term. We respect the sign. So I get x plus 5 all squared. That's what we call the perfect square. Now, the cool thing here, though, is on my factors, if I'm looking at my second example, 5 is the half of 10. And if we think of 3 is the half of 6. So we're going to start working on that. Let's take a look at this. We're going to solve this by the quadratic equation by completing the square. I'm going to, first of all, move the 10 over. So I get x squared plus 8x. I'm going to leave myself some space. And this is equal to negative 10. Going to complete a square. I want a number that completes a square. So I'm looking at my middle term. As long as my leading coefficient is a 1, I'm just looking at my middle term. And I'm thinking, what's the half of 8? I'm even going to write it. The half of 8 is positive 4. Once I write it so I don't forget it, and 2 because I'm going to use it. Okay, so I saw the half of 8 was 4, and then I even square it. Thinking 4 squared, it's 16. I'm going to add 16 to each side of the equal sign. I'm going to add 16, and I'm going to add 16. The reason why I did that is x squared plus 8x plus 16. All that simplifies to x plus 4 squared equals negative 10 plus 16. That is equal to 6. Now, to get rid of the square sign, I'm going to do the square root, and I'm going to end up getting that x plus 4 is equal to radical 6, and x plus 4 is equal to the negative radical 6. Let me subtract 4 to each side. X equals negative 4 plus radical 6. Let me subtract 4 to each side, and I end up getting x equals negative 4 minus radical 6. Let's take a look at another example, but first we're going to practice. First thing, it says find a constant to be added to get a perfect square trinomial and then factor it. Because my leading coefficient is 1, right? The number at the very front is a 1. I'm just looking at the middle term. And I'm thinking, what's the half of positive 4? And that will be positive 2. Square it. 2 squared is me 4. So I'm going to add a 4 to make it a perfect square. Then the way I'm going to factor it will be x plus 2 all squared. Same thing with example B. I'm looking at my middle term. The half of negative 2 is a negative 1. Then I square it. Negative 1 times negative 1. That gives me, I'm going to add a 1. So I'm going to add a 1 to make it a perfect squared, because once I factor it, this will factor to t minus 1 all squared. Same thing with C. I'm looking at the middle term. What's the half of 5? I'm looking at this as a fraction, and I'm going to say the half of 5 is 5 halves. I'll square it. Let me square it. 5 over 2 all squared gives me 25 over 4. So I'm going to add 25 over 4 to make it a perfect square. And once I factor it, it's going to factor it as m plus 5 over 2 all squared. All right, so let's practice a little bit more. I'm going to write this as x squared minus 6x. I'm going to leave myself some space, and this is equal to 12. So I'm thinking, what's the half of negative 6? The half of negative 6 is negative 3. I square it. Negative 3 times negative 3 gives me positive 9. So I'm going to add a 9 to both sides of the equal sign. So I'm going to add a 9, and I'm going to add a 9. The left side, x squared minus 6x plus 9, that factors as x minus 3 all squared. The right side, 12 plus 9, that is 21. So I made it a perfect square. That way, I'll be able to do the square root. So I get x minus 3 is equal to the positive square root of 21, and x minus 3 equals the negative square root of 21. Let me add a 3. So I get x equals 3 plus the square root of 21. Let me add a 3. X equals 3 minus the square root of 21. Let me move the negative 1 over. So I'm going to have k squared plus 5k, some space in there, is equal to 1. All right, so thinking what's the half of 5? I'm going to call it 5 over 2. I'm going to square it. 5 over 2 times 5 over 2. That gives me 25 over 4. So I'm going to add 25 over 4 to each side. The left side, k squared plus 5k plus 25 over 4. When I factor it, it factors as k plus 5 over 2 all squared equals. Now the right side, my 1, let me rewrite that as 4 over 4. Right, 4 divided by 4 is 1. I just wrote it like that so they will have common denominators. Now when I combine that, 4 over 4 plus 25 over 4, that gives me 29 over 4. So 4 over 4 plus 25 over 4 gave me 29 over 4. Same denominator, I just added the top. So I'm going to do the square root. So I'm going to get that k plus 5 over 2. Now, the square root of 29 over 4 can also be seen as the square root of 29 over the square root of 4. So I'm going to call that radical 29 over 2. And I also get that k plus 5 is equal to the negative radical 29 over 2. Now, when I move the 5 over, I see it's a common denominator too, so I'm just going to combine my numbers on the top. However, I want the radical last, so I'm just going to call this negative 5 plus radical 29 all over 2. When I subtract this as a 5 over 2, they have a same denominator. I'm just going to look at my numerators. Negative 5 minus radical 29 all over 2.